Welcome to our deep dive, and today we're looking at multimodal document question answering. You sent in a research paper about a new system called VisDoM, and wow, this is exciting stuff. I'm really eager to, kind of dig into what makes it so innovative with our expert. It's basically, getting answers from documents,
Right.
but not just, plain text. We're talking charts, tables, slides, a whole other level.
Yeah, it's fascinating. We use so many visuals to get information across, but most systems that answer questions have really been trained on text mainly.
Oh,
So to get them to understand charts and tables, I mean, this opens up a whole new area.
it really does. And speaking of that, the researchers actually put together this new benchmark, VisDoM bench.
Yeah.
It's a data set,
hmm
and it's meant to test how these systems do with this mixed media content, right?
Mm.
What makes VisDoM bench special?
Mm.
What's unique about it?
Well, it's designed to be a really complete test. It uses documents from all kinds of different areas, so it's not just limited to one particular field. And really importantly, each question in Wisdom Bench has annotated evidence, so researchers can trace how the system got to its answer.
Oh, so it's totally transparent. That's going to be so valuable to really understand how these systems pick. So, okay, now let's get to the star, VisDoM, the new system that uses this retrieval augmented generation approach. Can you unpack that a little? What does that even mean?
Well, retrieval augmented generation, RAG for short, it basically mixes that traditional information retrieval thing, like searching a database. It mixes that
Right.
with what large language models can do. It's leveraging what both are good at.
So it finds the info first and then uses the language model to make it understandable for us humans, right?
Okay.
But how does it deal with having both text and the visuals? That seems like a real challenge.
Well, that's one of the really innovative things about VisDoM. It uses separate pipelines, one for the text and one for visuals, each with its own steps.
Okay, so let's break that down a little. What do these pipelines, what do they actually DO?
Okay, so the text pipeline, that one focuses on, the text itself, finding key phrases, seeing how sentences relate, getting the context, and the visual pipeline. That one's all about analyzing the charts and tables, pulling out data, seeing trends, how visual elements connect.
So it's like two specialist teams kind of working the problem from their own angles. But then how do they come together? Do they just, I don't know, smash the results from the two pipelines together?
Not quite. They call it a consistency constraint to combine what both pipelines found. So it's basically checking if the text and the visual information are telling the same story.
Huh. Interesting. So if the text says profits are up, but the chart is, showing a downward trend, VisDoM could be like, hold on, something's not right here.
Exactly. It uses that inconsistency to look closer, figure out what's going on. Maybe the text is talking about a specific product while the chart's about overall company profits.
Yeah.
And it's that ability to make sense of different sources. That's what makes VisDoM so unique.
Yeah, I see. So how'd VisDoM do on VisDoM Bench? Did it live up to the hype? I'm dying to know.
Oh, it did. It really did. It did better than quite a few other systems, even some really powerful large language models that were, just given the whole document. The researchers also looked at specific examples, and VisDoM, it just consistently showed this amazing ability to synthesize information from all these different places within a document.
So it's not just pulling out random facts. It's actually putting the pieces together, building a whole answer. That's pretty incredible. But I mean, any new tech, there's got to be some limitations, right?
Yeah. Oh, for sure. One of the challenges is the cost, computationally. VisDoM, it leans heavily on these large language models, which, well, they can be real resource hogs, especially when you've got complex questions or super long documents.
Right. So scaling it up could be a bit of a hurdle. What are some of the other things, the challenges that the researchers are working on?
Well, they're trying to find ways to optimize the system, make it less computationally expensive. And they're also looking at how to deal with even more complex document types and trickier questions. This is really just the start.
It sounds like it. A ton of potential here. What are some of the real world applications that you find most exciting? What gets you fired up?
One area that jumps out is scientific research. Imagine researchers could quickly synthesize information from tons of scientific papers, no matter how complex.
Yeah, that could really speed things up in scientific discovery. What about in other fields?
Financial analysis, for one. Analysts have to go through mountains of reports, often with all these tables and charts. A system like VisDoM could really make that whole process smoother, faster, more efficient, especially for finding those key insights.
And I can see it being a game changer in education, too. Students could ask questions about their textbooks, and instead of just getting a snippet of text, they get a fully fleshed out answer with all the charts and diagrams and everything.
Oh, totally. It could totally change how we learn, how we access information. And that brings up a really interesting question. The researchers, they had to use optical character recognition, OCR, to get the text from the document images. What if there was a way to analyze the visual layout and formatting directly?
Huh. That's interesting. Could we go beyond just recognizing characters and actually understand the visual language of documents?
Exactly. Like a bold heading in a table, a steep line going up in a chart, those visual cues, they mean something, right? If we could teach systems to get that visual language, it could lead to even more accurate, more efficient question answering systems.
So it's like we're not just reading the words, we're reading the page itself.
That's a great way to put it. And it opens up all these new possibilities. Imagine asking, like, what's the connection between the data in this chart and the information in this table? Or how does the color in this presentation, how does that contribute to the message?
Wow. That kind of understanding, that would be incredible. But let's shift gears a bit. Think about the people, working with documents today. What are some key takeaways from this research? What should they be thinking about?
One of the big ones is that visual presentation matters. We spend a lot of time getting the words right in our documents, but sometimes we kind of forget about the visuals.
Yeah, we don't always think about how the layout, the formatting, the visuals themselves, how they affect how well the message gets across.
This research really shows how important those visual elements are. We're talking to humans, and humans, we're visual creatures. We respond to images, to colors, to patterns. We got to design our documents with that in mind.
So it's not just what we say, it's how we say it visually. It's about making documents that are both informative and engaging.
Exactly. And the other big takeaway is that we're on the edge of a huge change in how we interact with information. Systems like VisDoM, they show that we can build machines that get both text and visuals that can reason with them.
That's a really powerful idea. It could change how we access information, how we analyze it, how we use it in so many fields.
It really could. And it's not just about making new documents. Think about like a system that could take a really dense technical report and be like, hey, here's how to make this clearer, more visual, so more people can get it.
Yeah, that'd be huge, especially in fields like science or engineering where, you got to explain complex stuff to different people.
Right. It could help bridge that gap, between the experts and everyone else, make those topics easier to grasp. And it could also, help make knowledge more accessible. Anyone could get to it and understand it no matter their background.
That's a powerful thought, all driven by these amazing advances in AI and natural language processing. It feels like we're really onto something big here.
I think so too. We're seeing all these technologies come together, and it could totally change how we learn, how we talk to each other, how we interact with everything around us.
As we wrap up, what are some final thoughts you'd like to leave our listener with? Anything you're particularly pondering?
Well, the research we've been talking about today, it's really just the beginning. There's so much more to discover, and I can't wait to see where this field goes.
Well, we've certainly covered a lot in this deep dive. We've looked at the challenges of getting answers from documents with all these different kinds of media, the breakthroughs that are making it possible, and the potential this has to change how we deal with information.
And we even touched on some pretty cool ideas about how to use these same techniques to make our own documents better, more engaging.
To our listener, we really encourage you to dig into this more. We've put links to the research paper and some other resources in the show notes.
We're all part of this. But thanks for joining us on this journey of discovery.